As the name suggests, it was theory proposed by Newton. Because it is theory, practically it may or may not be true. So Newton suggested that source of light emits tiny, weightless, perfectly elastic particles and gave them the name as corpuscles. Source of light emits tiny, weightless, perfectly elastic particles. Source of light emits tiny, weightless, perfectly elastic particles called as corpuscles. Elastic means it will rebound back. Second, he said, these corpuscles travels in a straight line. Hence, light travels in a straight line. Write 2 points. This is one of the easy chapter we are doing. After completion of wave optics, 3 small chapters are left out. This is longer.
Done, sir.
Okay. Third, why we are able to see any object? Because we have eye. That's why we are able to see.
Yes.
In eye, there is retina. And on the retina, images are formed, so we are able to see. So this light, when they falls on retina, they will give form some image.
Yes, sir.
This image goes to nervous system, which will invert this image, and we see the person erect. Here it is formed inverted image. So these corpuscles strikes retina of eyes. Hence, we feel sensation of vision. Fourth, light are of different color. When people started asking him, he said, see, every corpuscles, they are tiny, but every tiny are of different size and shape. They may be spherical, they may be conical, they may be cylindrical. So he said different colors, practically, which you also know, color depends upon wavelength. Different colors are due to different sizes and masses of corpuscles. Different colors of light are due to different sizes and masses of corpuscles. Yeah, written till 4 completed.
Yes, sir.
Okay. Fifth, velocity of light in denser medium is greater than velocity of light in denser medium is greater than velocity of light in rarer medium. These corpuscles are repelled by reflecting surfaces. Hence, phenomenon of reflection can be explained. Right, another two. These corpuscles, they get repelled. That was suggestion by Newton. Hence, he said there can be reflection observed due to light. These corpuscles are attracted by these corpuscles are attracted by refracting surfaces. Hence, phenomenon of refraction can be explained. So the 7 points are corpuscular theory as suggested by Newton. Yes, completed all the 7 points.
Yes, sir.
Okay. So Newton's corpuscular theory. When Newton expired, then people started doing experimental deduction, whether his suggestions were correct or not. And they found that almost everything was wrong. So drawbacks of Newton's corpuscular theory of light. Drawbacks of Newton's corpuscular theory of light. First drawback. See, if source of light is emitting particle, तो कुछ दिन के बाद उसका वजन और size कम होना चाहिए. That means if I've got one tube light at my home, every week it should decrease in size, every month, every year a state should come when it is vanishing. But it is not found so. Size and mass remain same. So this could be the first drawback of Newton. If source of light emits particles, then its size and mass must decrease, but it is not found so. Second, experimentally, it is found that velocity of light in rarer medium is greater than velocity of light in denser medium. Right. Two drawback. Two more are there.
Done, sir.
Okay. Third point. Different colors of light are due to different wavelengths. Fourth, he said if the surface is reflecting, then light corpuscles will come and get repelled. And if refracting, then it will come and get attracted to the other medium. That means simultaneously I cannot have repulsion and attraction in any medium. So he could not explain simultaneous phenomenon of reflection and refraction. So corpuscular theory failed to explain corpuscular theory failed to explain phenomenon such as failed to explain simultaneous phenomenon of reflection and refraction. Right. Completed, right?
Yes, sir.
Okay. So we found that almost all the Newton's theory came as a drawback. If there is drawback in one, other scientist got the chance. His name was Huygens. Huygens wave theory of light. First, light travels in the form of waves. Light travels in the form of wave. Because it is traveling in the form of wave, he gave second theory, different colors of light are due to different wavelengths. Different colors of light are due to different wavelengths. Third, velocity of light in rarer medium is greater than velocity of light in denser medium. Right. 3 point. Light travels in the form of wave. Different colors are due to different wavelength. Velocity of light in rarer medium is greater than velocity of light in denser medium. Written this 3 point, I think.
Yes, sir.
Yes, sir.
Okay. Fourth point. People started asking, Huygens, you are telling that light travels in the form of wave, and we have heard that wave is a disturbance which requires material medium. How come this light is traveling through the vacuum around sun and reaching to the earth? He had no idea how the light is traveling in vacuum. Actually, lights are electromagnetic wave. He didn't have this idea. So he proposed one theory. He thought everywhere oxygen is there for survival. If it is not in pure form, it will be attached to some functional group. What is this called as? This functional group? Any name for this? Yes, any name for this functional group? Nobody knows what is ROR dash? हेलो,
कीटोन कीटोन
नहीं कीटोन नहीं, ईथर बोलते हैं ना इसको, ईथर है ना ये तो, कीटोन है ये,
No, sir. Ether.
ईथर है ना, हुआ नहीं क्या अभी तक ये चैप्टर? हेलो,
Yes, sir.
if it is not done then you might not be knowing. Is it done? Hello, this chapter is done?
Yes, sir.
Okay. So he thought that everywhere luminiferous मतलब जो चमकेगा ऐसा वाला particle present, and that is helping to send the wave through vacuum also. Still scientists are struggling to check where is that ether particle present everywhere surrounding sun. That means it was just a myth or false statement suggested by Huygens. So he said every where luminiferous ether particles, everywhere luminiferous ether particles are present, which helps propagation of light waves even in vacuum. Right. I think done. Just one point we have to write. Clear it?
डन सर
Yes, sir.
Okay. Drawbacks of Huygens wave theory of light. Drawbacks of Huygens wave theory of light. First drawback, the existence of luminiferous ether particles is not yet found. Second, suppose this is one cardboard, this is another cardboard, this is third cardboard, we are placing in a line parallel to each other. If we have one pinhole here and here we have a candle, then light should travel in a straight line and pass through this. This is called rectilinear propagation. So he has no idea how light is traveling, because as per him, light is like a wave. So if it is passing through here, light आएगा, crest आया और नहीं आया, pass हुआ, तो disco light जैसा होना चाहिए, wave का form. He could not give idea how this light is traveling in a straight line. So Huygens theory failed to explain. Actually, intensity is a square of amplitude. He didn't have idea. Huygens theory failed to explain the rectilinear propagation of light waves. It could not give information of light traveling in a straight line. Failed to explain rectilinear propagation of light wave. This also written, I think.
Yes, sir.
Okay. Third point. Huygens theory could not explain the phenomenon such as could not explain the phenomenon such as photoelectric effect. Photoelectric effect is based on particle nature of light. He could not explain how that light is behaving as particle nature. Photoelectric effect, Compton effect. Compton effect is when light passes through electric magnetic field, it shows some deflection. He could not explain this. Right. Third drawback.
Sir,
Yes.
you have written could.
Could not. I have given you any planner.
No, sir.
This week I didn't give you any planner.
No, sir. Not of this week.
Okay. This week clear all your backlogs if you have any. Tuesday I will give you a fresh planner so that again you can start executing that. Any backlog, please clear it off. Even class is not there Thursday, Friday, Saturday, Sunday.
Done, sir.
Okay. Next heading, right? Wave front. Now, clear front मतलब आगे आगे रहेगा ना कुछ तो. Wave मतलब disturbance आगे आगे रहेगा. What is meaning of locus? In maths you have studied. What is locus? Yes. What is locus?
Points on circle.
No, it can be any points. If you say circle means it is set of points which are at same distance from fixed point called as center, that is called locus of that is called circle. If I take
Yes, sir.
points which are equidistant from end point of a segment, then I will say this locus is perpendicular bisector. So locus पे हम लोग focus करते हैं under certain points which follow certain geometrical condition. Now, so what is then wave front? Wave front. It is locus of all the particles of medium. Locus of all the particles of medium. It is locus of all the particles of medium which receives light disturbance simultaneously. Locus of all the particles of the medium which receives light disturbance simultaneously and are in same state of vibration. Same state of vibration means all moving outward, all moving downward, all moving upward together and are in same state of vibrations is called as wave front. There are three types of wave front. First, spherical wave front. Second, cylindrical wave front. Third, plane wave front. Now write this definition. Once you complete, please tell.
Done, sir.
Done, sir.
Now, one by one, we'll see how we can get spherical wavefront, cylindrical wavefront, and plane wave. Name itself suggested it is theory wala chapter. Wave optics, here we are doing wave theory of light part in that. Spherical wavefront. Spherical wavefront. Suppose we take point source of light. Point source of light. Where it will give you light? In all direction or only in one direction? If this is one point source of light, it will give light in all direction or only in one direction?
All direction.
All direction.
Yeah, very true. All direction it will give me the light wave. With same speed or different speed? With same speed or different speed?
Same.
Same speed. That means if speed is c, then in time t second, all wave will cover same distance ct from this point source O. All will cover same distance.
Yes, sir.
All will cover same distance. Same distance. Same distance. Same distance. So if I cover all the particle in the medium which has got disturbance everywhere, up, down, right, left, and enclose it, can I feel it will be like a sphere?
Yes, sir.
So that collection of all the particles which have got disturbance simultaneously and are in same state of vibration is called as spherical wave front. So I'm just writing how we can get this. Consider a point source of light situated, the medium where velocity is same is called isotropic homogeneous medium, such as air. So consider a point source of light situated in an isotropic homogeneous medium such as air. It will emit light waves in all direction with same velocities. Let c be the velocity of each wave. Hence, in time t second, each wave will cover same distance ct. Thus, all the particles of medium which are at ct distance will, okay, just draw this diagram and then write everything. which are at distance ct will receive light disturbance simultaneously and are in same state of vibrations. A surface drawn passing through all these particles represents a sphere called as spherical wavefront. Complete. Full wavefront, spherical wavefront will end. Yes, completed.
Yes, sir.
Second one, cylindrical wavefront. Cylindrical wavefront. So if we consider linear source of light AB situated in an isotropic homogeneous medium such as air, it will emit light waves in all direction with same velocity. Light wave in all direction with same velocity. So each wave will cover distance CT. Thus, all the particles at the distance CT will receive light disturbance simultaneously and are in same state of vibration. If I cover all those particles throughout, it will behave like a cylinder, or it will appear like cylinder, called as cylindrical wavefront. So consider cylindrical, consider a linear source of light situated in an isotropic homogeneous medium such as air. It will emit light wave in all directions with same velocity. If c is the velocity, then each wave will cover distance ct. Thus, all the particles at distance ct will receive light disturbance simultaneously and are in same state of vibration. Surface drawn passing through all this particle represents a cylinder called as cylindrical wavefront. Draw diagram. Consider linear source of light AB situated in an isotropic homogeneous medium such as air. It will emit light waves in all directions with same velocities. Let C be the velocity of each wave. Hence, in time t second, each wave will travel same distance ct. Thus, all the particles at distance ct will receive light disturbance simultaneously and are in same state of vibration. Yes. Complete the diagram. Diagram you all have drawn.
Yes.
Okay, first line I am just rubbing. Completed? Yes, completed full?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so that's all for today. Please revise. This is totally theory. So that next lecture when you